Hello people, welcome one and all to Jojo's Learning Club.
Hello guys, welcome back to my channel once again. So this is the part 2 on exponential functions, and on this section I will be discussing further work problems on exponential functions. So in the last lecture I've already discussed on how to evaluate exponential functions using scientific notation calculator and also using power series. So let's do some further work problems with exponential functions. Before that, we already know about the exponential function is using power series, right? So what it is? E raised to x is equal to 1 plus x raised to 1 by 1 factorial plus x raised to 2 by 2 factorial, x raised to 3 by 3 factorial, and so on. So the power series of e raised to x may be also used to find or to evaluate any exponential functions in the form a into e raised to kx, where a and k are constants. So write the power series of 5 into e raised to 2x. So what can we write for here? 5 into e raised to 2x. So what is the difference in this series and this series? Here the value, the raised to term is x, and here it is 2x. So what you have to do? For x you have to substitute 2x in these equations. So how will be the formula changing? 5 is common for everything. So 1 plus 2x whole raised to 1 by 1 factorial by 2x the whole square by 4 factorial plus 2x the whole cube by 3 factorial, and so on. So these exponential function can be also used to find the or evaluate exponential functions in the form a into a is what here? A is the 5 and e raised to kx. K is what? 2. These both are constants. Using the value formula for exponential function power series for exponential functions, you can also evaluate the value of exponential functions in the form a into e raised to kx. So this is a small reminder. Now let's come back to problems. So we have here 4 work problems in total. The first 2 work problems are based using scientific notation calculators, and the rest 2 we will find using power series. Before starting the video, I would highly recommend everyone to practice with me while I am doing it in the whiteboard. Also, please have a scientific notation calculator with you while you are doing your work problems. Okay, so let's start. Okay, so let's start. You should, as I said, you should have a scientific notation calculator like this. So I am using the FX87DE series. Okay, so let's start with the first work problem. A 0.0256 e raised to 5.21. How to find the exponential functions using calculator? Press on shift, then press on the log button, then press on shift, then press in the log and button. So now the e raised to term will be appearing in the formula. Okay, oh sorry, appearing in the calculator. So just type here 5.21. So what you will get? 183.0.9 minus again e raised to again here e raised to 2.49. It is 12.06127. I'm taking up to here I took only up to 2 decimal places. Let me evaluate it again. So e raised to 5.21, 183.09405. I'm taking up to 5 significant figures. Okay, so now here 183.09405 minus 12.06127. So let's find what it is. It is 171.03278, and it should be multiplied with what? 0.0256 into 0.0256. You are free to do any way you wish, but I just wanted to show you how to take exponential functions using scientific notation calculator. Okay, so the final answer is what? 4.37843. So this is up to 5 decimal places I have written. Oh, it is said only to write up to 4 decimal places. So you just your final answer would be 4.3784 is your final answer. Okay, now let's do the B part. B part. What it is? 5 into e raised to 0.25. Again, press shift, then press on the ln button. 0.25. What it is? E raised to 0.25. That is 1.284025. Okay. The next, I am writing it up to 5 decimal places only. Otherwise, it will be a long time to evaluate all these values. So 1.28402. Again, let's check what is e raised to minus 0.25. What is the value? 0.7780. Okay, again write it down again here. It's the same, right? 1.28402 plus 0.7780. Now let's find the final answer. For that, add all these terms together. So I'm taking a bracket here. If you have a scientific notation calculator, it's much more easier to do the problems. 1.28402 minus 0.77880. Again, you come out of the bracket, divided by, again you put a bracket. What it is? 1.28402 plus 0.77880. Delete, I did a mistake here. Yeah, 880. Close the bracket and now find the value. It is 5 into 0.24491. Let's evaluate what is the value of it. So its value is somewhere around 1.224585. So I just did these two problems just to show you how to evaluate values using scientific notation calculator. You just have to press on the shift button first and then press on the ln button to get the e raised to term in the scientific notation calculator. I hope it's clear. So now let's do the problems using power series. Okay, the first problem, 5 e raised to 5 e raised to 0.5, correct to 5 significant figures by using the power series. So I need to find 5 e raised to 0.5. Let's take this 5 term outside itself. First, let's find what is e raised to 0.5, and then these values can be multiplied with 5 to find the final answer. Again, you need a scientific notation calculator to do it fastly. Otherwise, it is a really time consuming process if you don't have a calculator with you. Okay, so let's directly start. What is in the 4 series? 1 plus x raised to 1 by 1 factorial, x raised to 2 by 2 factorial, plus x raised to 3 by 3 factorial, x raised to 4 by 4 factorial, and so on. I am taking only up to 5 terms. Okay, so what is the series? 1 plus e raised to 0.5, that is 0.5, plus 0.5 the whole raised to 2 by 2 factorial is what? 2. I am writing just as 2. Okay, 0.5 whole raised to 3 by 3 factorial. 3 factorial is what? 3 into 2 into 1. 3 factorial is the product of first 3 natural numbers. So 3 into 2. Again, what is here? 0.5 whole raised to 4 by 4 factorial. 4 factorial is again the product of first 4 natural numbers. So what it would be? 4 into 3 into 2. That is 24. Okay, just I am rewriting it again. So what it would be? 1 plus 0.5 plus 0.5 the whole square by 2, plus again what it would come here? 0.5 the whole raised to 3 by 6 plus 0.5 the whole raised to 4 by 24. Okay, so now let's find the final answer. Okay, 1 and 0.5 I am already writing it here. Next again 0.5 the whole raised to 2 divided by 2, that is 0.125. Okay, now let's find what is 0.5 the whole raised to 3. Whole raised to 3 is 0.125 divided by 6. What would be the value? 1 divided by 48, that is 0.02083. I am writing only up to 5 decimal places. Okay, you can write up to any number of decimal places, but for the time being, as it is a time consuming process, I am writing only up to 5 decimal places. So next one is what? 0.5 whole raised to 4. 1 by 16 divided by 24, that is 1 by 384, that is 0.00260. Okay, now let's add all these together. So that is 1 plus 0.5 plus 0.125 plus 0.02083 plus 0.00260. So what's the value? 1.64843. Now let's find directly using scientific notation calculator what is the value of e raised to 0.5. So when we directly calculate using scientific calculator, the value is 1.64872148. Up to 3 decimal places you can see that the values are correct, but then on the value is not correct because it is only an approximation what you get from the power series. Power series, because I have taken only up to 4 terms, 5 terms. If I would have taken up to 8 terms, these value would have been much closer to the value in the scientific notation calculator. So up to 3 decimal places our answer is correct. So the value is find using this is correct. And to find the final value what it is, you have to multiply this term with 5. So let's multiply it again. 1.64843 into 5. The answer is 8.24215 is your final answer. So now let's find the last and the final problem in this section. Expand e raised to x into x square minus 1 as 5 terms, x square minus 1. So you have to expand this up to 5 terms. So what I'm going to do, again, you know the power series what it is, 1 by x by 1 factorial, that is x by 1, plus x square by 2 factorial, that is x square by 2. Again, what it is, x cube by 3 factorial, what it is, 6. I'm going to write it directly as 6. Again, x raised to 4 by what it is, x raised to 6 by 4 factorial, right? 4 factorial is what? 24. It is said to write up to 5 terms. Actually, this is a power series is going on, but it's only up to 5 terms. 1, 2, 3, 4, 5. So I've already written the 5 terms. Okay, maybe I have to try up to 5 number of x terms. So I have to include just x raised to 5 too. So what it is, 120. And the series goes on. I'm considering only up to 5 x terms. Okay, into x square minus 1. So what I have to do is, this is like an algebraic multiplication, right? First you have to multiply all these terms with x square, then multiply all these terms with minus 1. So let's do it. X square plus x square into x, that is x cube, right? Again, what it would be here, x raised to 4 by 2. Again, what it would be here, x raised to 5 by 6, right? Again, what would be here, x raised to 6 by 24. Again, what it would be here, x raised to 7 by 120, right? Am I doing right? I'm just multiplying all these terms with x square. So x raised to 5 by 120 into x square, what it is, x raised to 7 by 120. Again, write all these minus terms. So what happens, all these terms will have a minus with it. So minus 1 minus x square by 2 minus x cube by 6, then what, minus x raised to 4 by 24 minus x raised to 5 by 120 and so on, right? Minus x raised to 5 by 120. Now let's group all these together with terms with x square terms and together x cube terms together and so on. So let's write the final expression, minus 1 minus x square minus x square minus x square by 2, what it is, plus x square by 2, right? Okay, so what is the next term, x cube minus x cube by 6, what it would be, 5x cube by 6, right? So what is the next term again, x raised to 4 by 2, x raised to 4 by 2 minus what it is, x raised to 4 by 24, right? So what I have to do here, I have to multiply with 12. 12x raised to 4, 11x raised to 4 by 24, 11x raised to 4 by 24. Next term is what? X raised to 5 by 20, that is 620. So it is 19x raised to 5 by 120. And what are the next terms left? X raised to 6 by 24, x raised to 7 by 120. So this is your final answer. I hope it's clear. So in this section, we have done. We have discussed on how to evaluate exponential functions using a scientific notation calculator, and also how to evaluate exponential functions using power series. So on my next video, we will discuss on further work problems using exponential functions and Napierian logarithm. So this will be the last section on exponential functions. So for the time being, so I am signing off. Let's see you over in my next video. Bye bye. Take care.